Hello all, I am Dr. Gayathri, working as Assistant Professor of Chemistry in SNS College of Engineering. Today we are going to see about electrochemistry. It is a branch of chemistry in which the conversion takes place about chemical reaction into electrical energy or electrical energy into chemical energy. The conductance and basic conductance and types of the conductance we have seen in the previous videos. Here we are going to see about galvanic cell, etc. Let's move on to the topic. Galvanic cell, it is also called as electrochemical cell. In that we have already said the electrochemistry is the two conversion. It has two conversion. The first conversion is the chemical energy converted to electrical energy, and the second conversion is energy converted to chemical energy. The first type of the conversion is the best example for the first conversion is galvanic cell. In that the chemical energy is converted to electrical energy. It has two half cell, that is anodic half cell and cathodic half cell. The anodic half cell is also called as anodic compartment, and cathodic half cell is called as cathodic compartment. There are two types of conductor, that is anodic and cathodic. Anode compartment is one half cell and cathode compartment is another half cell. These half cell is combined to get a cell, the whole cell. That is here we are seeing about the galvanic cell. So the anodic compartment and cathodic compartment, there are two types of half cells. These both are combined to get a galvanic cell. Okay, in the anodic half cell oxidation takes place. In the cathodic half cell reduction takes place. We all know anode is loss of electron or gain of electron. Yes, it is. Oxidation is a loss of electrons, reduction is a gain of electrons. So at anode a loss of electron takes place. At cathode reduction takes place. In the anodic half cell oxidation, and in the cathodic half cell anodic oxidation and cathodic reduction takes place. Here in the galvanic cell the anode is zinc and the cathode is copper. Here we have taken two compartment, anodic compartment, cathodic compartment. In the anodic compartment we have taken the electrode as zinc, which is dipped in the electrolytic solution, that is a zinc sulphate. And here the cathodic compartment, here the electrode is copper, which is dipped in the electrolyte as copper sulphate. So zinc dipped in zinc sulphate solution, copper dipped in copper sulphate solution. So both the compartment has electrode, one electrode and electrolyte. Here in the anode zinc and zinc sulphate solution, here cathode copper and copper sulphate solution. Both metals zinc and copper act as a electrode, two electrodes. Here in the pictorial representation, the both electrode is combined with the voltmeter, to find out the volt produced in the solution. These two compartment is combined with a salt bridge, which is usually a U-type salt bridge we have used here. It is filled with agar-agar or KCl for the movement of ions. The salt bridge function is that it allows the ions to flow from one compartment to another compartment. Here anode to cathode. Here anode oxidation takes place, the loss of electron, and the cathode the reduction takes place, the gain of electrons. So here the salt bridge is U-type, which is filled with KCl, agar-agar solution, or etc. Okay, here anode at anode zinc is losses 2 electrons, and these electrons is captured by the copper at cathode, and that is reduction, and the overall reaction is zinc loss of electrons and copper gain of electrons, and the overall output of the voltage is 1.1 voltage. The overall output of the current through galvanic cell is 1.1 voltage. See here, copper electrode is positive and zinc electrode is negative, because here from the zinc the ions is transferred from the cathode of copper. So while for gaining it the symbol is positive, for losing the symbol is negative. The oxidation takes place, we all know, at anode, and reduction takes place at cathode. So the current flows from anode to cathode. The voltmeter function is it carry out the reaction, and it follows the ions movement in these two solutions, and defined the amount of current flows. That is, for galvanic cell is 1.1 volt overall voltage. Thank you all.